Hello everyone, today we're going to be going over the Part B of the June 2022 Regents Physics exam. We're going to be starting off with question 36, which asks which graph best represents the motion of an object traveling at a constant positive velocity, right? So our question is pertaining to velocity, it's asking about velocity. So I'm just going to list the formula. I know that V is equal to displacement over time, or d over t, and I'm also noticing that these graphs are given giving us displacement, which is our y, in terms of time, right? Y over t, right? So whenever we have a formula, obviously the formula to this, or to any formula, is going to be y equals mx plus b, right? So m is obviously going to be our slope, right? If we look at our slope here, slope is always going to equal to y1 minus y2 over x1 minus x2, right? But what I'm trying to get at here is that the format of the slope is always going to be in terms of y over x, right? And if we look here at our graphs, right, really our displacement is our y. Our displacement is our y, right? And our time is our x, right? So really, what I can say is that our slope here is going to be displacement over time, or d over t, right? And if our slope is displacement over time and velocity is equal to displacement over time, I know that my slope here is going to be v. And because I know that my slope is going to be v from that, I could write the formula displacement, or d, is equal to v times t. Easy. Now that I know that my velocity, that the velocity is the same thing as the slope in this line, I'm just going to have to match it with whatever parameters they give me. They say that it has to be positive, so I'm going to go ahead and I'm going to eliminate choices 2 and 4 because they're not positive, right? This one's going downwards, that means that's the negative slope, and this one is decaying, is exponentially decaying downwards, right? It's decay is always going to be negative, right? Now it says that it's constant, so I can eliminate choice number 3 and I'm left with 1. Why do I have to eliminate choice number 3? Because it's an exponential function, and in an exponential function your slope is never the same, right? Choice number 1 is linear because the line is straight, and if the line is straight, the slope does not change, which means that the velocity is constant. Moving on to number 37, it says a cannonball is fired with an initial VI of 100 meters per second at an angle of 15 degrees above the horizontal. What are the Vx and Vy components for this velocity? I'm going to go ahead, I'm going to just draw the scenario as I see it, right? So here I have my Vy, here I have my, that is not what I meant to draw, right? Here I have my Vy, and here I have my Vx, right? And then when I add these two components up, I'm going to get a speed of 100 meters per second at an angle of 15 degrees, right? So in order to solve this problem, I'm going to have to solve for either one of these given this angle and one side, right? And really what this is reminding me of is a trig function, right? So I'm just going to go ahead and I'm going to redraw this diagram as such, right? I'm going to keep my Vx the way it was, facing this way, right? And then I'm going to draw my Vy component facing upwards like that, right? All I did so far was I just drew this, and then I'm going to draw my velocity the same way, right? It's still going to be the thing on top, right? And in this case, I'm just moving my 15-degree angle right here. So all I did was I just flip this the opposite way, right? So now this is the same thing. It's just representing the exact same thing, just drawn differently. And now I could use trigonometry, right? So remember SOHCAHTOA, or really you just need SO and CA here to solve for that, right? So I'm going to set up my sine equation as sine 15 is equal to Vy, right, which is opposite over my hypotenuse, which is 100 meters per second, right? And I'm going to set up to solve for Vx as cosine 15 is equal to Vx, or which is my adjacent over my hypotenuse, which is 100 meters per second. And when you actually solve for Vy and you solve for Vx here, you're going to get choice number 1. Moving on to number 2, it says a 1,200 kilogram car is moving at 10 meters per second when a braking force of 3,000 newtons is applied. How much time is required to bring the car to rest, right? So really what I'm dealing here I'm dealing with braking force, right? I'm dealing with force applied over time, right? And I'm trying to bring it to rest. And whenever you're trying to bring something to rest, right? Whenever you're trying to break something, whenever you're trying to stop something from moving, let's just say I have a 10 kilogram block and I'm pushing against it with all my body weight, right? To stop it from moving, that's going to deal with momentum. that's going to deal with momentum. And right here, conveniently, I already listed for all of you, like all of the momentum formulas or formulas that can involve momentum, right? So P is equal to mv, right? So momentum is equal to mass times velocity. I also know that my P before is equal to my P after, right? So my velocity before is equal to velocity after. And I know that impulse, right, is just the change in velocity, change in momentum, right? I meant to say momentum, or force applied per second, right? So here, let's just calculate. So what I'm going to first do is I'm going to first calculate the force of the car, or the momentum of the car as it goes, right? We know that P is equal to mv. So I'm going to write P is equal to the mass, which is 1200 kilograms, right, times 10 meters per second. Right, and when I do this, I get P is equal to 3,000, just 12000 newtons, right? So that's the velocity that it's going at, right? Now I can use this formula, which is F times S, right? So impulse is equal to F times S, right? If I want to stop this, I'm going to have to put in a specific amount of impulse, right? Or a specific amount of force to cancel this out. If I have 12,000 newtons of momentum in one direction and I want to bring it to rest, I'm going to have to apply 12,000 newtons, or I'm going to have to apply 3,000 newtons of force in the other direction over a specific amount of time, right? So think about it, right? If J is equal to Fs, right, and I need an impulse of 12,000 newtons, right? I'm going to write down 12,000 newtons, which is the thing that I'm trying to stop, and this is equal to my force, my braking force, times time, right? So if I have something that's traveling with a momentum of 12,000 newtons, and I want to brake it, and I have a braking force of 3,000 newtons, right? How many seconds is that going to take? It's going to take 4 seconds, right? Because 3,000 times 4 is 12,000. And when 12,000 is equal to 12,000, that means I have enough momentum to stop I have enough force, right, to equal the momentum that is coming at in the opposite direction and just bring it to a complete stop, right? So the answer to 38 was 4. Moving on to number 39. I'll go ahead and I'll zoom out, right? It says, which graph best represents the relationship between the speed of light in a transparent medium and the absolute index of refraction, oh my goodness, in the medium, right? So I'm going to go ahead, I'm going to go into my reference table where it says waves. I know C is the speed of light and N is the absolute index of refraction. So which one gives me C, which one incorporates C and N? Obviously this one, right? And we're talking about speed and velocity, which is v. So which gives me c, n, and v? That's this formula, right? So I know that n is equal to c over v, right? And I just need to choose a graph, just like with number 36. I need to choose a graph that represents this relationship, right? So let's just rewrite. Everything is in terms of speed of light, right? Everything is, remember that everything is always going to be in terms of your y-axis, right? So in this case, my y-axis is speed of light. So I'm going to go ahead, I'm going to go into this formula, n equals c over v, right? And I'm going to go and I'm going to put this in terms of my v, or the velocity of light, right? And if I multiply by v on both sides, I get nv is equal to c, right? And if I divide by n on both sides, I get v is equal to c over n, right? Now, if we think about it, c is constant, right? The speed of light is always going to be the same. It's going to be 3.8 times, just 3 times 10 to the power of 8, right? Which, and since this never changes, this c never changes, the only thing that can change is this n, right? So think about it, right? If I cannot change my numerator, but I can definitely change my denominator, and if I increase my denominator, right, obviously the speed of light is going to go down, right? If my n is 1, the speed of light is not going to change, but if my n is 2, the speed of light is going to halve. If it's 3, it's going to be 1/3 of what it is. It's 4, like it's just going to get smaller, 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 and smaller, right? Say the speed of light was like 20 meters per second, right? And then if my index of refraction was 1, right, that wouldn't change. It would be 20, right? But if it was 2, then the speed of light would drop by 1/2, right? And it was 3, it would drop by even more. So what I'm trying to get at is when you put this in terms of the speed of light, right, or the velocity of light in the medium, right? It's the speed of light in the medium. It's going to equal to the speed of light divided by the index of refraction, right? And as the index of refraction increases, the speed of light has to decrease because it's in the denominator. That's all, right? Just basic division. Number 40 says a student uses a string to whirl a 0.25 kilogram mass in a horizontal circular path that has an 8 meter radius, or 0.8 meter radius. If the magnitude of the centripetal force exerted on the mass with the string is 25 newtons, right? What is the speed of the mass is what, right? So what are we given? We're given mass, right? We're given radius. We're given centripetal force, Fc, and we're trying to find velocity, or the speed of the mass, right? So let's go ahead and let's look at our formula table right here. And let's see which one incorporates all those factors, right? So here I have Fc is equal to m times AC, and here I have AC is equal to v squared over r, right? I'm trying to solve for v squared, and they give me FC. So I think what my game plan here is I'm going to have to first solve for AC, and then I'm going to put AC in terms of v squared over r, right? So that's going to become a lot more clear. First thing I'm going to do is I know I have to use both of these formulas to solve, right? And I'm just going to write them down, right? I'm going to zoom in, I'm going to write my first formula down. FC is equal to what? FC is equal to MAC, right? And my second formula, AC is equal to v squared over r, right? First thing first, they give me FC. I'm just going to plug FC into that, right? So what is the centripetal force? The centripetal force is 25 newtons, right? So here I have 25 newtons is equal to my mass, right? My mass is what? 0.25 kilograms, right? And that's going to be multiplied, right, by my AC, which they don't give me, right? They don't give me my acceleration. So in order to solve for AC, I'm just going to have to divide both sides by 0.25, right? And 25 divided by 0.25 is the same thing as 100, right? So my AC is actually 100 meters per second squared, right? Boom, we solved for one thing. Now I can plug this AC into the formula. AC is equal to v squared over r, right? Because they're asking us for the speed of the mass, which is v, right? So here I have 100 meters per second squared, and this is going to equal to my velocity squared, right, which is what I'm trying to solve for, divided by my r, my radius, right? And in this case, my radius was 0.8 meters, right? So 0.8 m. Next, I'm going to multiply both sides by 0.8, right? So 100 times 0.8 is 80, right? So now I'm left with 80 meters per second squared is equal to v squared. I'm going to take the square root of both sides, right? The square root of 80 is 8.94, roughly, right? And that's going to match up with choice number 2, right? That's it. Moving on to number 41, it says a deuteron is formed by combining a proton and a neutron. The mass of a deuteron is 2.39 times 10 to the negative 3 universal mass units less than the combined masses of a proton and a neutron, right? The mass difference is equivalent to what, right? So what they're saying is that this particle, and I'm just going to write that as a D, this is equal to what? A proton plus a neutron, right? And when we form this D, right, it is 2.39 times 10 to the negative 3 universal mass less. It's less. This side has less mass than this side. Why? Because whenever you form a bond, or whenever two things come together, right, you need energy. So some mass is lost in the form of energy. And now they're asking us this mass difference, right? Right? Think about it. This is the difference of mass, right? If something is X amount less, that means that the difference between this and this is exactly that, right? That is the difference if something is that much less, right? If here I have a dollar, I have something that's worth $15, and here I have something that's worth $20, right? The difference is 5, right? So if they ask me for the value of that difference, it's just going to be 5, right? It's going to be this side minus this side, right? So this side's mass minus this side's mass is equal to 2.39 times 10 to the power of negative 3 universal mass units, right? And now they're asking us what this mass is equivalent to, right? So the key word is that it's in universal mass units. And if I go into my reference table and I scroll all the way up, right, I have universal mass unit, right? I know that one universal mass unit is equal to 9.31 times 10 to the power of 2 mega electron volts, right? And I know that my answer choices are in MeVs, so I'm going to go ahead and I'm going to use that, right? So if I need to know what 2.39 is equal to, I'm just going to have to convert it, right? So here we have 2.39 times 10 to the power of negative 3 units, right, is going to equal to what, right? So let's just set up a proportion, right? I know that 1 universal mass unit, so I'm going to write 1u, right? Because I want these 2 units to cancel out. And I'm going to say that that's equal to 9.31 times 10 to the power of 2, right? So this is going to equal to 9.31 times 10 to the power of 2 mega, or just EV. Oh, sorry, mega electron volts, right? So MeV. But what's going to happen when I multiply these two is that this universal mass unit, is going to cancel out, and I'm just going to be left with 1 times mega electron volts, and that's going to give me my MeV, right, which is the format of my answer. And if you actually multiply that together, right, the answer is going to be 2. This is going to give you 2.23 MeVs. So moving on to number 42, it says the gravitational force of magnitude F exists between Earth and a satellite on Earth's surface, right? The satellite is sent into orbit a distance of 3 Earth radii above Earth's surface as shown in the diagram below. What is the magnitude of the gravitational force between Earth and the satellite when the satellite is in orbit? Right, so we're talking about the magnitude of gravitational force, right? We're talking about gravitational force. So I'm going to go ahead, I'm going to consult my reference table. I'm going to scroll all the way down to where it says gravitational force, right? And right here it's saying force of gravity, or gravitational force, right? Weight or force due to gravity is equal to g m1 m2 over r squared, right? I'm just going to write that down, right? So Fg is equal to g m1 m2 over r squared, right? And if I don't know what m1 m2 are, right, m1 and m2 is going to be the first mass, the second is just going to be mass 1, mass 2, and in this case r, which is given right here, is going to be the radius or distance between the centers, right? So if I want to find out the r, right, so obviously first off, in order to calculate this, I'm going to have to multiply the mass of the Earth by the mass of the satellite, and then, right, I'm going to have to divide this. I'm going to have to divide this top value by the distance between the 2 radii, right? So between the radius of the satellite and the radius of the Earth, right? So they give us that the distance between the Earth and the radius of the Earth is r, right? And the distance is 3r. So the total distance between the radius and the radius of the satellite is going to be r plus 3r, which is 4r, right? So really r squared is 4r. And right here, it's saying that a gravitational force of magnitude F exists between the satellite and the Earth on the Earth's surface, right? So when we're on the surface, right, when r is just equal to 1, when r is equal to 1r, right, so that 1 squared is 1, this entire thing, right, Fg is equal to F, right? And that's when our denominator is equal to 1, right? So if this denominator is now equal to 4r, or if it's 4 times greater, right, what is that F? That F is obviously going to be 1/16 times less, right? Because if we really think about it, if this is 4r squared is the same thing as saying 16r, right? 16r because we're squaring it. So the distance, if the radius is 4, we square it, that gives us 16. And now we're dividing this f by 16. It's going to be 1/16 of what it actually was in the first time, or in the first place. So that's all. Moving on to number 43, it says, as a part of an investigation on quantization, a student recorded the mass of 5 identical containers, each holding a different number of pennies. The table shows the student's data, right? Based on this data, what is most likely the mass of 1 penny? Right? So just think about this, right? It doesn't matter what they give us in the data table. What matters is that a penny is really, 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 really light, right? So the answer is going to be probably the lightest thing here, which is 3.2 grams. Obviously, it's not going to be 12.8 grams, right? Because that's almost a tenth of a kilogram, or that's almost 100th of a kilogram. A penny is usually most likely going to be around 3 or 1 or 3 grams heavy, right? Moving on to number 4, it says, which graph represents the relationship between frequency and the period of a wave, right? So let's look in our reference table. Let's see if they actually give us that relationship. Here's period. Period is equal to 1 over frequency, right? So T is equal to 1 over F, right? In other words, period is equal to 1 over frequency. Remember that a graph is always in terms of the y-axis, right? So let's put this in terms of y-axis. I'm going to multiply both sides by frequency, and I'm gonna I guess be left with period is equal to frequency. I'm going to be left with period times frequency is 1. I'm going to divide by period on both sides, I'm going to get frequency is actually equal to 1 over period, right? So what I'm getting at here is that obviously there's not going to be, the answer is not going to be 2, right? Because if we really think about it, the frequency, this 1 cannot change, right? This 1 cannot change. The only thing that can change is the period, right? So as your period increases, your frequency is going to go down because you're dividing this number by a bigger number, right? So for example, if my period was 2, my frequency has to be 0.5, right? If my period was 3, right, my frequency has to be 0.33 repeating. The fact is that the higher my period, the higher the number that I'm dividing this 1 by, and the lower the value of my frequency, right? And the only one that really shows that is choice number 4, obviously, right? Because it's showing that as your period increases, as you increase this denominator, and as you increase the value that you're dividing 1 by, right, the value that you're going to get back is going to start sharply decreasing. So that's all. This is the only one that makes sense. Obviously, it doesn't increase. It doesn't stay the same, right? And this is, I don't know. It's not, that simply doesn't make sense, right? Because we just said that it decreases. Number 45 says, what is the current in a conductor if 3.5 times 10 to the power of 18 electrons pass a given point of the conductor in 10 seconds, right? So some things to note right here. They gave us the number of electrons, right? And they give us time, right? So time, number of electrons, right? And they also, our answer is in amps, right? If our answer is in amps or amperes, and they give me the number of electrons over a given amount of time, I'm going to have to look at a formula that gives me an answer in amps over a given amount of time and the amount of electrons, right? So which one is this? This is obviously going to be I, right? Because I is current. Current is measured in amps, right? This is the only thing that relates to amps. And this says that the change in charge over time, right? So here we had our charge, which is this many electrons, and here I have my time. Well, obviously, I can't just put in electrons, right? Because charge is in terms of coulombs, right? So first thing I'm going to do is I'm going to have to convert this to coulombs, and then I'm going to have to use the formula I is equal to delta Q over T, right? So first of all, let's go ahead, let's convert these 3.15 times 10 to the power of 8 electrons into blank coulombs, right? So I'm going to go ahead, I'm going to scroll all the way up to where I have that conversion chart, and here I can see that 1 coulomb, right, is equal to 6.25 elementary charges. Elementary charges are just electrons, right? So here, I know that 6.25 times 10 to the power of 18 E is equal to 1 coulomb, right? And these two E's are going to cancel out. And once you divide them, you're going to get your answer, right? Which I'll go ahead and plug into my calculator right now. 3.15 times 10 to the power of 18 divided by 6.25 times 10 to the power of 18. That's going to give you 5. Pretty much going to give me 5 point something, and then once we plug in that 5 point something, we're going to have to divide that by 10, and when you divide that by 10, that's going to give you an answer of 0.05 amps. That's all. Moving on to number 46, it says a particle with a charge of +3 nanocoulombs is placed in an electric field with a magnitude of 1500 newtons per coulomb. What is the magnitude of the electrostatic force exerted on the particle by the electric field, right? A lot of big words. Let's just see which ones are important, right? So it says a particle, right? And it gives us a charge, right? So it gives us Q, a charge. And it's talking about an electric field, right? So I'll just write that down, right? Electric field, right? And it tells us that that it's 1500 newtons per coulomb, right? So N over C. I'm just gonna write that down, right? And they're asking us the magnitude of the electrostatic force, right? So they're asking us Fe. They give us Q, and they're asking us for Fe. And we know that this is N over C, right? So let's look in the electric section, and let's see which choices match up with that, right? So obviously I have these two choices. I have Fe, right? This is Fe, and this is Q. But they don't give me radius, right? They never give me a distance, and they never ask me for a distance. So I'm not going to use this formula. I'm not going to use the electrostatic force formula. Instead, I'm going to use E, which is the electric field strength. Guess what? They give us the electric field strength, right? Which is E, and they give us they're asking us for the electrostatic force, which is Fe, force of electrostatic, right? You can find that here in this section, electrostatic force, right? And we're dividing it over Q, which is our charge, aka in coulombs, right? So I'm going to have to use this formula. E is equal to Fe over Q, right? E is equal to Fe over Q, right? So what do I know? I know that my E, right, my electric field strength, right, is going to be 1500 newtons per coulomb, right? And over C, right? And I'm going to set this equal to my force electric, which I don't know, which is Fe. And I'm going to divide this by, guess what? Plus 3 nanocoulombs, right? So that's going to be 3 times. And right here, if you don't know what a nano is, it tells you the conversion right here. It says that nano is 10 to the power of -9, right? So 3 times 10 to the power of -9. I'm going to have to multiply both these sides by 3 times 10 to the power of -9 to get Fe. And once I do that, I should get an answer of 4.5 times 10 to the power of -6 newtons. That's all. So moving on to number 47, it says the graph below represents the motion of an airplane that starts from rest and takeoff in a straight on a straight runway, right? And it's giving us velocity versus time. Now it's saying which quantity is represented by the slope of the graph, right? So all of this time we have been finding out the slope of the graph, right? So we should know what's up, right? So we're given velocity, right, in terms of time, right? And if I want and if I want to find the slope, right, that's going to be in the format of y over x or v over s, right? So if I go into my reference table, it could probably remind me of what v over s is. If I go into mechanics specifically, right, v over s, or in other words, v over t, right, because seconds is time, right? And that looks a whole lot like my formula for acceleration, right? A is equal to v over t, right, or delta v over t, right? Here I have v, which is my y, and here I have time, right, which is my t, or seconds, right? And if a is equal to delta v over t, and this graph is velocity over time, or velocity versus time, v over t, then this is going to give me my acceleration, right, because A stands for acceleration. Number 48 says the diagram below represents 2 horizontal platforms that are different heights above level ground. A ball rolls off the taller platform with a horizontal speed of 15 meters per second and travels through the air, landing at the top of the shorter platform, right? So this goes like that, boom, and it hits only the top, right? So it doesn't further fall down, it just hits this top. What is the total time that the ball is in air? Neglect friction, right? So if they are so let's just write everything that they give us, right? So it's obviously the thing that's going to determine its air time, right, is the distance, right, that it is from the ground, right? Obviously it's the distance that it is from here because it lands here. My horizontal velocity does not matter, right? It doesn't matter how fast it's going, right? It's always going to hit the same. If this was going 30 meters per second, guess what? It doesn't matter. It's going to hit the same time. It's going to hit the ground at the same time as something that's going 15 meters per second, because the only force that's bringing it down is the force of gravity, and that force of gravity, right, is always going to be the same, assuming that the weight doesn't change, right? So it doesn't matter, right? What I'm looking at here is I'm given height, right? I'm given acceleration, right, which is the force of gravity. I'm given my initial velocity, right, because it's from rest, right? It doesn't have any VIY, right? It doesn't have initial vertical velocity, right? So I'm given VIY. And I'm also given V final, right? And I'm also given distance, or h, right? And I'm trying to find my time, So let's see which formula gets all of that. Well, obviously, this formula is going to be d is equal to VIT plus 1/2 AT squared, right? So I'm going to go ahead, I'm going to zoom in, and I'm going to write that down, right? So d is equal to VIT, right? So V initial times time plus 1/2 AT squared, right? So here, my distance is going to equal to 6 minus 3.6, right? Because it only traveled the distance between these two, the tops of these two platforms, right? That's going to be 2.4, right? So 2.4 meters is equal to its initial velocity, right? Which I said was 0 because it's starting from rest, right? It's not like it's already falling, right? It's starting from rest, which is 0 times t, right? And I'm adding this to 1/2 times my acceleration, right, which is 9.81 meters per second downwards, 9.81 meters per second squared, right? It's going to be positive because it's going downwards, right? And I'm going to be multiplying this by my time squared, which is something that I don't know, right? So in reality, I have 2.4 meters is equal to 1/2 times 9.81 times x, right? And we're trying to solve for x. Multiply both sides, divide by 1/2 of 9.81, and you get an answer of 0.7 seconds, right? That's all. So just list your parameters, don't get confused, and then plug it into the right formula. 49 says 4 mechanical waves are created in the same medium over the same time interval. Which diagram represents the wave that transfers the greatest amount of energy, right? So remember that energy transfer is your amplitude. Right, the higher your amplitude is, the more energy that you're going to convey, or the more energy that wave holds. And obviously, choice number 3 is going to be your answer, right? Oh, sorry, choice number 2 is going to be your answer because that amplitude is the greatest out of any other graph, right? This amplitude is the highest, which means it holds the greatest amount of energy. And finally, number 50 says, which diagram represents a light ray increasing in speed as it travels from one medium to another, right? So here I have mediums, and the only thing that changes across mediums is each medium's index of refraction, right? And if I look back at my wave reference table, where it does give us the speed of light, right? The speed of a wave, depending on the index of refraction, that's going to be n equals c over v, right? Right, and if I put this back in terms of v, which is the velocity of the wave, I know that v is equal to c over n. In other words, the greater the index of refraction is, the slower the velocity the wave will travel, right? So really, what I'm trying to see is something that goes from a higher n to a lower n. Right? Because it's saying that the light ray is increasing in its speed, right? So it's going from a higher n, which means that you're dividing c by a larger number and in turn making it smaller, and it's going to a smaller n, which is then dividing c by a smaller number and making it less big, right? So whenever you have a higher n, obviously, it's going to try and it's going to go closer and it's going to hug the normal, right? High n means that it's closer to the normal, right? And a lower n means it's closer to just the solid non-dashed line or the surface, right? So automatically I can eliminate number 4, right? Because this isn't changing, right? As we go from medium A to B, it's the same thing. Both mediums have the same index of refraction because this light isn't changing at all, right? If I look at choice number 1 and I follow my rule, I say that higher ends tend to hug the normal, right? And if I go here, I'm going normally, and here I'm hugging the normal, which means that it's going from a lower end to a higher end, which is the opposite. I want to go from a higher to a lower end. And obviously choice number 3 is the one that says that. This one falls under the same issue. Choice number 3 is the right answer, right? That's all of part B2. Or just B1, right? If you want me to go over B2, which is the short answer section of this test, please let me know in the comments, right? Otherwise, I'll just be starting off with more multiple choice review for the, I believe it is the June 2019 test, right? So that being said, I hope you learned something. I hope you have a nice day. If you like this video, please leave a like. And if you want more content, please subscribe and let me know. Bye-bye.